Good afternoon. Today's topic is classification of lubricants. Let us see what are lubricants. The substances which are used to decrease the force of friction between the moving parts of machine in contact are known as lubricants. Means the substances which decrease the force of friction when the machine is moving, then that substance is called a lubricant. For example, we use mustard oil, grease, mobile oil, etc. to decrease the friction between two moving parts. Now, what are the characteristics of a lubricant? Means how can we say that a lubricant is a good lubricant? A good lubricant possesses the following characteristics: high boiling point, low freezing point, high viscosity index, thermal stability, corrosion prevention, high resistance to oxidation. Now, what is lubrication? The process of decreasing the force of friction between the moving parts of a machine in contact is called lubrication. So, it means कि when we apply a lubricant in a machine to decrease the force of friction, then that process of the application of a lubricant is called lubrication. So, the application of a lubricant is called lubrication. Now, what is the purpose of lubrication? Means why do we want to apply a lubricant? First, keep the moving parts apart. Means when the machine is moving, we have to keep the two moving parts away from each other. Second is reduce friction. So, when we keep the moving parts away from each other, this reduces friction between the two moving parts. Third, transfer heat. So, it means कि we want to transfer the heat generated during the force of friction, and we want to carry away that heat. Fourth is carry away contaminants and debris. So, we have dust particles in the air. So, we want to remove those dust particles from the machine. So, when we apply a lubricant, then those dust particles move away from the machine with the lubricant, and thereby they keep the moving parts clean. Fifth is transmit power. We want to transmit power clearly and effectively to the moving parts, and this can be done only with the help of a lubricant. Sixth is protect against wear. So, when the force of friction hits up the moving parts, then our machine gets lots of cracks in it, and those cracks are called wear and tear of the machine, and we want to protect our machine against that wear and tear. That is why we apply the lubricants. Seventh is prevent corrosion. So, there are dust particles, moisture in the air, and the machine is mostly made up of iron and steel. So, when these things meet with each other, they cause corrosion of the machine, and we want to prevent that corrosion. That is why we use the lubricants. Eighth is seal for the gases. Sometimes we do not want the gases to escape from the machine parts. That is why we apply the lubricants, and these lubricants act as seal for the gases. Next is classification of the lubricants. Now, if we are using the lubricants to decrease the force of friction, then what type of lubricants can we use? On the basis of their physical state, lubricants are classified into three types. First is liquid lubricants or the lubricating oils. Second is semi-solid lubricants or greases, and third is solid lubricants. So, it means we have liquids, that is oils, semi-solids, that is greases, and third solids or the powders. Now, what are the liquid lubricants or the lubricating oils? Liquid lubricants are those lubricants which on application reduce the friction between the moving parts and also reduce the wear and tear between the two moving parts of a machine by providing a continuous fluid film in between them. So, the oil which we apply in the machine, that creates a continuous fluid film. That is why the two moving parts remain away from each other, and this reduces the friction and wear and tear between the two moving parts. Liquid lubricants also act as cooling agents, means they take away the heat. Sealing agents means they seal the gaps between the machine, and corrosion preventers means they prevent the corrosion in the machine. Liquid lubricants should have low vapor pressure and high boiling point, that is, they should not vaporize at room temperature and also do not boil at room temperature. Next is high oxidation resistance, means liquid lubricants should not react with oxygen at room temperature. Third is non-corrosive nature. The liquid lubricants which we are going to use should not react with the metal of the machine. Next is good thermal conductivity, means they should be able to take away the heat produced by the frictional forces between the moving parts and thereby keep the machine cool enough for efficient working. Next is low freezing point, means the liquid oils do not freeze at 0 degree or even lower than that, so that in cold countries also these liquid lubricants can be used. Then is adequate viscosity for particular conditions. That means the liquid lubricants should flow properly even at higher temperatures and even at lower temperatures. Their viscosity should not change appreciably with the change in temperature. Then are types of liquid lubricants. We have synthetic oils, mineral oils, vegetable oils, animal oils and blended oils as lubricating oils. So, once again we have synthetic oils, mineral oils, vegetable oils, animal oils and blended oils as lubricating oils. First of all, let us see what are mineral oils. Mineral oils are also known as petroleum oils because these oils are obtained by the fractional distillation of petroleum at a temperature of about 400 degree centigrades. Means the crude petroleum is heated to 400 degrees centigrades and the fractions are obtained at different temperatures in the fractional column. These contain certain impurities like wax and asphalt extra, and these also contain aliphatic hydrocarbons with 12 to 15 carbon atoms, which can be removed by number of processes such as dewaxing, acid refining and solvent refining. So, the wax and asphalt which is present in the lubricating mineral oils have actually carbon atoms in the range of 12 to 15, and these hydrocarbons can be removed by dewaxing, acid refining and solvent refining. What is dewaxing? The wax present in mineral oil raises its pour point and renders the lubricant unfit for use at low temperature. In this process, the oil is mixed with suitable solvent like propane, mixture of benzene and acetone. It means we can use two solvents, either we can use propane only or we can use the mixture of benzene and acetone. The wax starts to become solid, which can be easily removed from the oil by filtering through a continuous filter. Means first of all the wax dissolves in the oil, from the oil into the solvent, then that solvent is cooled and the wax becomes solid, and this solid wax is removed by filtering through a continuous filter, and the solvent is removed by distillation. Next is acid refining. Now, the dewaxed oil contains number of unwanted impurities like asphalt, etc. For removing these, the dewaxed oil is treated with concentrated sulfuric acid and agitated. So, the dewaxed oil is now reacted with concentrated sulfuric acid. Now, some of the unwanted impurities are dissolved while the remaining are converted into sludge. Means some of the impurities are dissolved into the concentrated sulfuric acid and some of them settle down at the bottom of the tank. The oil is finally stabilized and decolorized by passing through Fuller's earth maintained at 110 to 140 degree centigrades. So, this mineral oil which has been dewaxed and acid refined, this is passed through Fuller's earth so that the color from it can be removed, and the temperature is kept at 110 to 140 degree centigrades. Next is solvent refining. Now, the mineral oil is mixed with a solvent like phenol. Now, phenol is added to the mineral oil and the unwanted impurities which are soluble in phenol, they go into the phenol, leaving the oil free of the impurities. Now, phenol being immiscible with the oil, that is phenol does not dissolve in the oil. The liquid forms different layers which can be separated easily. So, we have two layers, one is of phenol containing the impurities and the other is of oil. Now, from this oil is removed and the solvent is recovered by the distillation process. So, in this way we have the oil free of the unwanted impurities. So, this process removes unwanted impurities, and this reduces any chance of formation of carbon deposits during the use of lubricating oils in moving machines. It means that when we are using the lubricating oils, if they contain wax or asphalt, which are actually the hydrocarbons, so when these oils burn, then they will leave carbon. Now, if we remove these through dewaxing, acid refining and solvent refining, so the chance of having carbon deposits in the machine, that reduces. Next type are the vegetable oils. These oils are obtained from the vegetable sources. These were widely used before the discovery of the petroleum, but nowadays mineral oils have replaced them. That is, we were using vegetable oils as the lubricating oils before the use of the mineral oils. Now, these vegetable oils were such as mustard oil, coconut oil. These were routine oils which we were using. Now, still these oils are being used, or these are added to mineral oils for improving their properties. That is, we can use vegetable oils as such, or we can mix them with the mineral oils and improve their properties. Now, the types of vegetable oils which we usually use. First is olive oil or the sweet oil. Now, it is prepared by compressing the fruits of olive trees. Now, its color varies from colorless to golden yellow. The higher grades are used for edible purposes, while the lower grade oils are used for the lubrication of bearing and ordinary machine parts. So, that means कि olive oil is actually used for food, but the lower grade olive oil is used for the lubrication of bearing and the ordinary machine parts. Second is palm oil. Palm oil is pale yellow with pleasant smell. It is prepared from the kernels of palm fruit. Kernel means inner part of the palm fruit. Next is colza oil. It is extracted from the colza plant. Now, it is pale yellow oil with a characteristic smell. Next is castor oil. It is prepared from the seed of the castor. Now, its color varies from colorless to pale green. Next is hazelnut oil. It is prepared from the hazelnut. Next category is the animal oils. These oils are obtained from animal sources. These resemble vegetable oils in their properties. Now, these are added to mineral oils to improve their properties. So, it means the oils which are obtained from the animal sources are also added to the mineral oils so that their properties can be improved. Some of them are neat foot oil. It is prepared by boiling fat of neat with water. Second is whale oil. It is prepared by the distillation of fat of whale, which is a kind of fish. Then is lard oil. It is a colorless oil and is prepared from the kidneys and intestines of the pigs. Then is tallow oil. It is a transparent oil and is prepared from the fat of cattle and sheep. So, it means the animal oils are actually prepared from the fat present in the animals by the dehydrogenation process. When we dehydrogenate a fat, it releases hydrogen. It now contains double bonds and triple bonds and changes into the oil, which is liquid, and we use that oil as a lubricating oil. Next type is the blended oils. The oil obtained by mixing the mineral oil with vegetable and animal oil to improve their properties are known as blended and compounded oils. Now, if we use either vegetable oils or animal oils as such, then actually the problem is vegetable oils and animal oils are very weak oils. At higher temperatures, they actually degrade. That is why we have to mix these oils with the mineral oils. Now, these mixed oils are called blended or the compounded oils. The blending of oils is done to improve the pour point, oiliness, oxidation and corrosion resistance of the oils. Means if we want to improve these properties, pour point, oiliness, oxidation and corrosion, then we will have to blend the oils. Next are the synthetic oils. These oils are the chemically prepared compounds where mineral oils fail to work. The synthetic oils are used as lubricant. Actually, the synthetic oils are also the mineral oils, but they are actually prepared in the factories instead of getting it from the distillation of the petroleum. We prepare them in the laboratories, and their properties are much better as compared to the natural occurring crude oils. Now, these synthetic oils are very effective under severe conditions. The most commonly used synthetic lubricants are silicones, phosphates, esters and fluorocarbons. Once again, the synthetic lubricants are silicones, phosphates, esters and fluorocarbons. These oils are very expensive and sometimes they are used by mixing them with the mineral oils. Means we can mix these synthetic oils with the mineral oils so that their cost is reduced and the properties of the mineral oils are improved. Now, different synthetic oils are polyalpha olefin, which is known as PAO, then synthetic esters, then we have polyalkylene glycols, which is PAG, then is phosphate esters, then alkylated naphthalenes AN, then silicate esters and then ionic fluids. These are the different synthetic oils which we use in the industry. Then are oil additives, means to improve the properties of the lubricating oils, we have to add different substances into them. Only after adding these things, we send the oils into the market. A large number of additives are used to impart performance characteristics to the lubricants, and the main families of the additives are antioxidants, so that oxidation resistance is improved, detergents, anti-wear, metal deactivators, means if there is a chance of reacting with the metal, they do not react with the metal, corrosion inhibitors and rust inhibitors, means their corrosion resistance power is improved, then friction modifiers, that is force of friction is reduced, extreme pressure, that is they can work under extreme pressure conditions, then anti-foaming agents, that is they do not foam with the water, then viscosity index improvers, means the viscosity of the oil does not change appreciably with the change in temperature. Then we have de-emulsifying or emulsifying agents, then stickiness improver, that is it provides the adhesive property towards the tool surface, that is the oil remains stuck to the machine, it does not come off easily with the increase in temperature or decrease in temperature or the presence of the dust particles. Then complexing agents, in case of greases only we use the complexing agents which form complexes with the chemicals present in the greases. Then is application of the liquid lubricants. Now, liquid lubricants are used as anti-wear, antioxidants and anti-foaming agents, because we are adding these substances to the lubricating oils. Then as de-emulsifying and emulsifying agents, as rust and corrosion inhibitors, as engine oils, compressor oils, gear oils and piston oils. Then in machinery we are using the lubricating oils in engines, compressors, gearbox and pistons. As hydraulic, brake and gearbox fluids. Then these are also used in paint and soap industry. We use the lubricating oils in the paint and soap industry also. Then synthetic lubricants are used in turbines and semiconductor devices, because the temperature increases in the turbines and we need some oils which will not degrade with the increase in temperature, and in semiconductor devices we need something which will improve its performance. Then applications of the lubricating oils in the automation, as engine oils, as petrol engine oils, diesel engine oils and automatic transmission fluid. In tractors we use only one lubricant as universal tractor transmission oil, also called UTO, and super tractor oil universal, STOU. Then we use these lubricating oils in other motors and two-stroke engine oils. In industry we use lubricating oils as hydraulic oils, air compressor oils, gas compressor oils, gear oils, bearing and circulating system oils, refrigerator compressor oils, steam and gas turbine oils. In aviation industry, we use lubricating oils as gas turbine engine oils and piston engine oils. And in marine, we use the lubricating oils as crosshead cylinder oils, then cross head crank case oils, then trunk piston engine oils, then stern tube lubricant. Once again it is cross head cylinder oils, cross head crankcase oils, trunk piston engine oils, then stern tube